Good afternoon. This is John Lazarsk again with my third video, which is going to be part 2 of yesterday's video of the crush cans. All right, so just as a quick reminder, if we look at what happened yesterday, there I am again diving into science. There's my email and everything. Is we heated up a couple of cans, aluminum cans on the stove. And then we proceeded to place them in this. I think I called it a water bath yesterday. I meant to call it an ice bath, right? And here is the result. So basically, after yesterday, you had cans that were crushed like this. And I asked you to make a model. And I even showed you some examples of models. And if you recall, now yesterday, one thing I didn't kind of make explicit was these are two-dimensional models, right? Three-dimensional models are, like model airplanes and things like that. But I wanted you to put your thoughts down on just a regular sheet of paper, like most scientists do for the first time, is they come up with these conceptual models on a sheet of paper first. So hopefully you might have written a model about, or drawn a model about what you think happened here, okay? So, and you may have been thinking, like this poor little orange yesterday, going, wow, I have no clue what happened to the cans. My goal today is to give you a little bit of new knowledge to turn that around to some kind of a aha moment where, whoa, now I kind of get it. And maybe not get you all the way there today, but get you a little bit closer to what the heck is going on with the cans, right? So, what you did yesterday was something what I call first draft thinking. Okay, we've all written some kind of an essay and we put our first draft thoughts down, and it's kind of what you're thinking at the time, and it's never perfect. It's always kind of messy. In your model's case, what I mean by messy is science-wise. Maybe the perfect explanation isn't quite there yet, right? But I'm not too concerned about you having to get that perfect explanation on your first try. Got to be like scientists who there may be 1, 2, 3, 4, 5 trials before they finally kind of get it. Kind of like what's going on today with the coronavirus. Science are trying to put together models, and there's just so many variables. Those models are changing by the day based on the data that they're collecting. So to help you out today with your models is I want to give you some new knowledge, or help you, give you more information to help you with your models. And because we always want to revise, refine, and add to our models based on this new information, new knowledge. And that new knowledge can come in the form of data, research, videos, experiments. The number one thing that I really love is when you talk to scientists, they have conversations with other scientists. So maybe in your classroom, you can have a conversation with another student and get some new knowledge that way, because there's 30 some people in the classroom. That's a lot of knowledge there to share. And if you just start to talk to someone else, and later on in some of my videos, I'll give your teachers some ideas about what this academic conversations might look like, okay? So, new knowledge. I was thinking yesterday about the phenomena of the cans, and and whenever I think of phenomena, I think of how can I think about this in another way, in a way that's very similar? And then I thought about, there's times when I'm out exercising, or I'm getting all, sweaty and hot, and I come in and I need to drink some water. And here's a plastic bottle. And sometimes I'm so thirsty, I drink this thing and I get to the end of it and this happens. Did you see that? You're done with all the water, and pretty soon this plastic bottle is kind of doing the same thing as this aluminum can. So my question is, what do you think is causing this? I'll do it one more time. What is going on to make this happen that could be very similar to what made this happen? And if you recall yesterday, I had you start to think about what is something that we can't see that may be causing this. Something around us that we cannot see that may be causing this. So this is kind of my new knowledge for the day. Think about this, right? And for those of you either in 5th grade or middle school or high school, I also want you to think about, when I heated up the cans first, I want you to think about what happens to objects when they are heated. Most importantly, think about what might have been inside the can, right? I did tell you to put a little bit of water, but what might have been inside the can that could have caused, or what when you heat it up, what happened to the objects in the can? And then when I placed it in the cold water, think about what happens when things get cold. What happens to the particles when they get cold? And could that help you try to figure this phenomena out? Well, I hope it does. And that's it for this video of the phenomena of the crushed cans. So I hope you guys have some pretty good ideas of why this might happen. You can also go on YouTube, find some videos. Just to let you know, tomorrow I'll be doing another video, but this one's going to be more for the little kids, and it's going to help you answer the question, do I have to touch things to get them to move? Until then, I'm signing out. You guys all have a great day. Take care.